Good morning, dear students. We have already seen the many topics in wave optics. Last video that we have seen about the reflection wavefront and how mathematically it is proved that sin I by sin r equal to a constant. Okay, angle of incidence and angle of refraction is equal. How it is in mathematically, that is what we have seen in the last class. Now we are going to see about refraction of plane wave. We have already seen reflection. Now we are going to see the refraction. Okay, refraction you already know. So the wave which is going from one medium to another medium. Okay, so there it is only one medium. The light is coming from one medium and it is reflected to the same medium. Here the light is coming from one medium, that is comparatively air, and it is entering into the another medium, denser medium compared to the air. That is what we are going to see here. How the light is coming, as a ray, and what is wavefront, how it is considered as a wavefront, and how it is penetrating, how the penetrating wavefront is created. That is what we are going to see discussing here. Okay. So now, if you see, this is a boundary surface. Boundary means this is one medium. This is one side of the medium. This is another side of the medium. The line which separates the two different medium is called boundary surface. Okay, so this is the arrow mark which indicates that it is an incident ray. Incident ray, it is not single. So many rays which will come over here. Okay, it is an incident ray, and this is medium 1. Can you see here? This is medium 1. Consider this medium as air. Okay, and second one, this is medium 2. Consider this somewhat water or rectangular glass slab, any denser medium compared to the air. Okay, so now what will happen? The light ray comes and hits here. Each point where it come in contact, it creates the secondary wavefront. Okay, and second ray comes and hit here, and secondary wavefronts are created at the second point. And third ray comes and meet at a boundary, and the wavefronts are created. And fourth ray comes and meet here, their wavefronts are created. This is the first wavefront. So the secondary wavefront which created is somewhat of bigger, because the time taken for the first wavefront to propagate in one particular direction is more compared to the subsequent wavefronts which is created. This is the first wavefront. First wave comes and hit here. This is the second wave. This is the third wave. This is the fourth wave. So that the wavefront is just now it is created, so that it will be very small. So what we will do usually to determine the wavefront, we will connect all the tangent of the secondary wavefront. Tangent, can you see this line? This line passes through each of the secondary wavefront. Okay, so this is a refracting wavefront that we can consider here. Okay, there we have seen reflected wavefront. This is a refracting wavefront which is created in this particular manner. Okay, so this is for your understanding how the incident ray comes in here, and if it is reflect means how it is reflecting, and if it is penetrating means how it is penetrating, how the wavefronts are created here. It is as an illustration which is given as a diagram. Okay, just this is for your idea. Next, if you see here, the refraction of plane wave. In refraction, when any point of incidence, the wavefront interacts with the boundary. Interacts with the boundary means where it comes and hits the boundary. The secondary waves are generated and they will have same velocity. Secondary wavefront which is generated and they will have same velocity means reflected will have same velocity. When it penetrates, the speed of the light will change. Okay. What is the case 1? It is rarer medium to denser medium. That means rarer medium means consider this as air. Denser medium means consider this as a water or something. Okay. So the wave is generated in one medium and have the velocity of v1 into t. How we are considering this as v1 into t, that we have already discussed. Okay. So waves denser medium will have lesser velocity. Why it is lesser velocity? Because denser medium, the speed of the light will change. Speed of the light will decrease, so that it is denser medium. The velocity will change in rarer medium to denser medium. So it is v2 into t. So the wavefront will not be a circle as the wave in two different mediums are traveling with the different velocities, because it cannot be a complete circle. It travels little bit slow in the second medium, little bit faster in the first medium, so that it will vary. Okay, so what we are going to prove is to prove the Snell's law. How we are going to prove the Snell's law is the thing which we are going to see here. Okay, well, if you consider this diagram, this is the incident ray comes and hits here. Okay, this is medium 1, this is medium 2. Incident ray comes and hits here, and after refraction, while penetrating, it moves towards the normal. Okay, moves towards the normal, and it is going over here. This is a refracted ray. So how the rays are coming? The rays are coming like this. 1 minute. The rays are coming like this as a 3 straight lines. Okay, if you consider this in a wave form, how it will come? It will come like this, like a wave. It will come over here. Okay, in this same diagram, imagine how the light is coming. If the rays are coming like this, how we can consider this as a wavefront? The same phase we will draw. We will connect all the phases, all the same phases in a if we connect this, that is considered as a secondary wavefront. So if we connect this, this is how the secondary wavefronts are created, so that it will be a straight line. So actually, what is this? This is the incident wavefront. So can you understand how incident wavefront is in this manner, and how incident ray is coming? This is incident ray. This is incident wavefront. Okay, this is one more ray which is coming over here, which comes and hits a particular point. Okay, and this is also coming and meeting this particular surface, and here the ray meets first, and this particular point, it will take some time to reach over here. It will take some time to reach this particular point. For example, this is the first ray comes and meet here. This is secondary wavefronts are created, 2-3 lines are forming over here. This is second meeting point, second point, where only 2 or 3 circles only which is created, 3 wavefronts are created, and the third point, 2 wavefronts created, and the last point only just 1 wavefront only created. So like this, the wavefronts are generated like this. So this will take time. A last ray will take time to reach a particular point in the boundary. That point is considered as the distance. The distance is already we have already seen how we can determine the distance of a wave. Distance d is equal to v1 into t. v1 is the speed which is considered for one particular medium into time taken. So that is the distance which it can move to over here. That is what I have written it here. To reach from B to C, it will take the time as v1 into t. Similarly, this distance is more and this distance is less. Why? Because the speed of the light will decrease in the medium to denser medium, so that it will be v2 into t. Okay, so it will be v2 into t, and this will be v1 into t. Two different velocities because two different mediums. So this is angle of incidence, this is angle of refraction for the wavefronts. So what we are going to prove? N sine theta is equal to constant. That is sine A by sine R that we are going to prove. Refractive index into sine theta is equal to constant. That is what we are going to prove it here. I hope this diagram will help you to understand how the diagram that we have drawn it out here. And let us see the mathematically derivation part of it. Let us consider two different triangles. One is triangle A, B, and C. Second one, triangle A, E, C. Okay. So in these triangles here, sine theta means it is opposite by hypotenuse. Okay. What is opposite here? This is opposite. Opposite is BC. Hypotenuse is AC. Okay. So that it is BC by AC. And sine R, angle of refraction R is equal to what is opposite AE divided by hypotenuse AC. This is AE by AC. We already know that what is Snell's law? Sine A by sine R is equal to constant. So sine I by sine R. What is sine I? BC by AC into what is sine R? AE by AC. So it will become reciprocal AC by AE. What will happen? AC and AC will get cancelled. So if both get cancelled, what is the leftover? BC by AE is the leftover. So BC, what is BC here? BC is the distance where the light ray starts from B and reaches C. So what is the value of it? D is equal to V1 into T. So instead of BC, I'm writing this as V1 into T. And instead of AE, we are writing this as V2 into T. We are substituting the value for it. So T and T will get cancelled. What is the leftover? V1 by V2. Okay. So we already know what is refractive index. Absolute refractive index, we know that refractive index is equal to speed of light in vacuum divided by speed of light in medium. So if we want the V value, V will go there and N will come down. So V is equal to C by N. So for V1, it is C by N1. For V2, it is C by N2. So we are substituting the value of V1 and V2 in this here. So sin A by sin R is equal to, instead of V1, we are substituting this as C by N1 and V2 C by N2. C and C will get cancelled. So what will happen? Denominator will go to numerator. So sin I by sin R is equal to N2 by N1. So we know Snell's law, sin A by sin R is equal to constant. So that cross multiply, if we cross multiply, what will happen? N1 into sin I is equal to N2 into sin R. This is what we are going to prove when it comes to refraction of a plane wave from one medium to another medium. If you see here, the mathematical expression also, sin A by sin R, it is V1 by V2. Refractive index, the same thing. What I have written over there, it is given in a printed format. Okay, I hope you understand this very well. Next video, we are going to see is the different cases, case 1 and case 2, regarding the refraction of light in different medium. Okay, make a note of it in the classwork note so that you can refer it at any time. Thank you.